Hey everyone, and welcome back to the channel where we explore the most mind-bending what-if scenarios the universe can throw at us. Today, we're tackling a question that sounds simple but unravels into pure cosmic chaos. What would happen if a needle, just a regular sewing needle, hit the Earth at the speed of light? Now, before we dive in, let's get a couple of physics ground rules straight. According to Einstein's theory of relativity, nothing with mass, like our tiny needle, can actually reach the speed of light. It would require an infinite amount of energy. So, for the sake of our thought experiment, let's just get it incredibly close. Say 99.999 and a bunch more 9% the speed of light. At these speeds, things get weird, really weird. As our needle accelerates, its mass, from our perspective here on Earth, would increase exponentially. A tiny 1-gram needle would suddenly have the effective mass of something much, much larger. And with that mass comes an absolutely staggering amount of kinetic energy. We're not talking about the energy of a bullet or even a bomb. We're talking about energy on a planetary scale. The equation for kinetic energy is 1/2 mass times velocity squared. And when that velocity is nearly the speed of light, the numbers go off the charts. So, picture this. A super-fast, supermassive needle is hurtling towards our planet. What happens at the moment of impact? The instant it touches our atmosphere, it wouldn't be like a simple object entering. It would be a cataclysmic energy release. The air molecules in its path wouldn't have time to get out of the way. They would be instantly vaporized, triggering a chain reaction of nuclear fusion. Yes, fusion. The needle would essentially act as a trigger, creating a column of superheated plasma, hotter than the core of the sun, that would stretch through the atmosphere. On the ground, no one would even see the needle coming. The first sign of trouble would be an unimaginably bright flash of light, followed by a thermal pulse that would incinerate everything for hundreds, maybe thousands of kilometers in every direction. This isn't just a fire. It's a wave of pure heat that vaporizes cities, boils oceans, and turns landscapes into glass. Simultaneously, the impact itself would unleash a seismic shockwave of apocalyptic proportions. The needle wouldn't just make a crater, it would punch through the Earth's crust like it was tissue paper. The resulting earthquake wouldn't be a 9 or 10 on the Richter scale. It would be a scale-breaking event causing the entire planet to ring like a bell. This global earthquake would trigger volcanic eruptions and tsunamis on a scale we've never witnessed, dwarfing anything in recorded history. But the devastation doesn't stop there. The impact would eject a colossal amount of debris, rock, dust, and vaporized earth, high into the atmosphere and even into space. This massive cloud would spread around the globe, blocking out the sun for years, maybe even decades. This is what's known as an impact winter. Without sunlight, global temperatures would plummet. Photosynthesis would grind to a halt, leading to the collapse of nearly all plant life on land and in the sea. This, in turn, would cause a mass extinction event, wiping out the entire food chain from the bottom up. The world would be plunged into a dark, frozen wasteland. The few humans who might have survived the initial blast, heat, and earthquakes in deep underground bunkers would emerge to a world they wouldn't recognize, a sterile, frozen planet under a perpetually dark sky. Let's think about the crater for a moment. It wouldn't be a simple bowl shape. The sheer energy release would be so immense that it would likely fracture the tectonic plate it hit. The resulting chasm would expose the Earth's mantle, unleashing a torrent of magma that would continue to reshape the surface for centuries. The planet's very geology would be permanently altered. So, to recap the sequence of events, a flash of light, an instantaneous wave of heat vaporizing a continent-sized area, a planet-shattering earthquake triggering global volcanoes and tsunamis, and a cloud of debris causing an impact winter that leads to a total collapse of the biosphere. It's safe to say this is an extinction-level event, far more powerful than the asteroid that wiped out the dinosaurs. That asteroid was a big rock. This needle is a bolt of pure cosmic energy. The sheer scale of this is hard to comprehend. The energy released would be equivalent to trillions of nuclear bombs detonating at once. The comparison is almost meaningless because the effects are so fundamentally different and more profound. We're not just talking about destroying civilization. We're talking about effectively sterilizing the surface of the planet and resetting the clock on life itself. Could life ever recover? Maybe. Deep-sea vent organisms that don't rely on sunlight might survive. And over millions of years, as the dust settles and the sun's light returns, perhaps simple life forms could begin to evolve again. But human life, and all the complex ecosystems we know, would be gone in a flash. It's a terrifying thought, but it's also a powerful reminder of the incredible energies that govern our universe. A simple object, given an impossible speed, becomes the ultimate weapon of planetary destruction. It's a testament to the power of EEOMC2, where even a tiny bit of mass can unleash an unfathomable amount of energy. Thankfully, there are no spacefaring civilizations, that we know of, launching needles at us, and the laws of physics make this scenario purely hypothetical. But exploring these extreme what-ifs helps us appreciate the delicate balance that makes life on our beautiful blue planet possible. It's a fragile system, and one we should definitely do our best to protect. What do you think? Is there any way Earth could survive? Let me know your thoughts down in the comments below. I love reading your theories and ideas. Thanks so much for watching and for joining me on this wild cosmic ride. If you enjoyed this and want to explore more mind-bending questions, be sure to hit that like button and subscribe to the channel so you don't miss our next adventure. Until next time, stay curious